What's up, guys? Welcome to another wonderful day of math class. It's good to have you here. I'll be talking about recursive equations today. Get this up a little bit so you can see my full face. Awesome. So today we'll be talking about writing an equation from a recursive function. So this first pattern that we're going to be talking about is 0, 3, 6, 9, 12. What I always like to do in a recursive equation is I like to write in the x values. So I'm going to write in my step values, and we're going to start with step 1. This first guy is step 1, step 2, step 3, step 4, and step 5. The next step in a recursive equation is to figure out how much it's going up by each time. The difference, the common difference in this case, is 3. So our common difference is 3, and that's going to help us write our equation. The very first step is to write what a recursive equation looks like. And they are always going to look the same. They're going to have f of n on one side, and they are going to have f and n minus 1 in the subscript. So this n minus 1 is referring to the step before. And then all we have to do is add or subtract our common difference. In this case, that's plus 3. So our recursive equation looks like this. F of n equals f of n minus 1 plus 3. We also have to give the first step. In this case, the first step is 0. So f of 1 equals 0. Moving on to the explicit part of the equation. Once again, we know our common difference. And we know what an explicit equation looks like. It looks like y equals something x. Okay? Our common difference is always going to go right in front of our x because we are multiplying it every time. So y equals 3x is the start of our explicit equation. Now we just have to make it work. So we're going to plug in values. We're going to plug in our x value and our y value and make sure that the statement is true. When we plug in a 1 for x, our y value is 0. So 3 times 1 is 3, and we have to force that to equal 0. In this case, we would subtract 3. Since I need to subtract 3 from the equation to make the equation work, I'm going to put that in my equation. So the explicit equation for this guy is y equals 3x minus 3, right? And let's see if that works. For step 2, we have 3. Plug in a 2 over here. 3 times 2 is 6, minus 3 is 3. That is correct. Let's try that 5. 5 times 3 is 15. 15 minus 3 is 12. So we've successfully written our recursive equation and our explicit equation, and they work for all values. Moving on to another one. So the first thing we want to do in any recursive equation is to fill in our x values. Our x values are going to be related to the step. So the first one is 1. This 7 right here is 2, 3, 4, and 5. Step 1, 2, 3, 4, and 5. Next, we're going to look for our common difference. In this case, it's changing by 7 every time, and it's changing by a -7. So our common difference in this case is a -7. Now that I have those two things done, I'm going to go ahead and write my recursive equation. They always look the same. F of n equals f of the previous step, and we write that by n minus 1, referring to the step before. And then all we have to do is add or subtract our common difference. In this case, it's -7. Last step on the recursive is we're going to start at step 1, and f of 1 equals 14. So to reiterate, f of n equals f of n minus 1 minus 7, and the first step is step 14. That is our recursive equation written out. Now we're going to write our explicit. Explicits always look like y equals x. We're going to plug in our common difference in front of the x value, so that's a -7. And we have to figure out where we are starting. So if we start at 14, then we need to make that equation work for the point 1, 14. Our first step is 1. Our first y value should be 14. When I plug in a 1 value here, -7 times 1 is a -7, but we need it to equal 14. So -7 plus what equals 14? -7 plus 21 equals 14. Let's see if that works for all the other steps. I'm going to start with the easiest step, step 3. I plug in a 3, -7 times 3 plus 21 will equal 0. So we know we are correct. The explicit works for each of the problems, or each of the steps. Awesome job. Moving on to a little bit harder. The first step, like always, is we label our steps. So we got step 1, step 2, step 3, step 4, step 5, and step 6. The next step we're going to do always is look for a common difference. In this case, we got 2, then we got 4, then we got 8, 16, etc. So we can see that it's not going up by the same amount every time. So this is considered a geometric sequence. It's going to look like a parabola, and it's not going to be as easy to do. First off, let's write our recursive equation. It's always going to look the same. F of n equals f of n minus 1. Right? And then our common difference is changing every time, and we need to determine whether it's going up or down. It's going up, the numbers are getting bigger, and they are getting bigger by a factor of 2. So in this case, we are multiplying our recursive equation by 2. If we want to get from one step to the next, that's what we're doing. We're taking the previous step, multiplying it by 2 to get 32. Okay, last part of the recursive is we just have to figure out where it starts. And f of 1 in this case equals 2. And the first step equals 2. For our explicit, it's always going to look like y equals x, something. In this case, since we know it's a geometric sequence, our x is going to be an exponent. Okay, so we're going to have something raised to the x value. I know right off the bat that we are multiplying by 2 from our recursive equation, so our base is going to be 2 in our explicit equation. Y equals 2 raised to the x power. Does that work? So at step 1, we plug in a 1 value for our x. 2 raised to the first power is 2. It works for this first step. Let's try step 4. We plug in a 4 for our x value. 2 raised to the 4th power is 2 times 2 times 2 times 2. And or 4 times 4. And 4 times 4 is 16, so we know that our explicit equation works in this case. Awesome. Moving on to the final version. Nope. Moving on to the last problem of today. In this pattern, we have 100, 50, 25, 12.5. We're going to start by labeling our steps. 1, 2, 3, 4. And we're going to figure out what's happening between each step. So it's going down by 50, then by 25, then by 12.5, then by 6.25. So we can see that it's going down by half, right? To go from 100 to 50, we multiply by 1/2. We could also say divide by 2, but as you'll see in the explicit equation, it's much easier to multiply than it is to divide. So our recursive equation for this guy looks like f of n equals f n minus 1 for the previous step. And then what are we doing to each step? We are multiplying by 1/2. So this would be times 1/2. Okay? Last step is we need to figure out where we start, and f of 1 in this case is 100. That is our recursive equation. Now for the explicit equation, once again, y equals x. Since we know that this is not going down by the same amount every time, it's going to be a geometric sequence again. So we know that our x is actually an exponent, okay? Our common difference in this case is we're multiplying every time by 1/2. So our base in this problem is going to be 1/2. All right, 1/2 to raise to the x power. Let's see if that works for step 1. So we plug in a 1 for x. 1/2 raised to the first power is just 1/2. So what do we need to multiply this guy by to get to 100? If we were multiplying by 1/2, our first value would be 200, right? Because if we multiply 1/2 times 200, we would get 100, which would be our very first value. Let's see if it works for the second guy. 1/2 to the second power would be 1/4. 1/4 times 200 is 50. So we are correct so far. So to make this look a little cleaner, I'm going to write the 200 in front. So it'd be 200 times 1/2 raised to the x power. And that would be our explicit equation, works for all of those. Hopefully that all made sense to you guys. Please ask any questions if you have them. Your quiz on Friday will be pretty much exactly this. I will give you a pattern. You will write me an explicit and a recursive function for the pattern. So please, if you don't understand how to do this still, either ask a question or come to the Wednesday review session when we will be working on it some more. Thank you so much, and please return to the live classroom.